This assessment asks us to predict the product of the reaction on screen. Now we note that this is a reaction between an alkene and a carboxylic acid in the presence of sulfuric acid, a strong acid itself. This is reminiscent of the alkene chemistry we studied previously, where alkenes can react as nucleophiles or bases with strong acids. And so we can show that first step is to protonate that alkene. We have two possible carbocations we could make. We're going to make only the tertiary carbocation in this case. Now, we've seen carbocations like this attacked by bromide or water or chloride or alcohols. It turns out that carboxylic acids can react as nucleophiles in this reaction as well. So the carboxylic acid oxygen, the oxygen of the carbonyl, will be the most nucleophilic oxygen here and will share a pair of electrons with the empty p orbital. This is going to give a reagent or an intermediate that might look kind of odd because it's got a positive charge on oxygen that is doubly bonded. But if we think about what this really is, this is an oxygen that attacked and brought along its proton. Now you might say, what? There's not a proton on this oxygen. And you're right, there's not. But when this oxygen attacked, it brought along this proton. And so in the final step, we could use any base in solution, most likely because we would try to exclude water from this reaction. The most likely base would be the alkene itself. This alkene can remove this proton, allowing these electrons to go down, pushing those onto that oxygen. So it's a new version of an oxygen that's brought along a proton, and in the second step, we remove that proton. We're doing the same thing here. But if we do that, if we draw the product that those arrows tell us are going to form, we end up with this as our ester. So we've essentially we've done a nucleophilic addition, or an electrophilic addition, of a carboxylic acid to an alkene through this mechanism. It should look very familiar. Protonate, make a cation, nucleophile attacks, remove a proton to give that product. Before I go, it dawned on me a question might come up. What happens to this? Well, the product of this alkene removing that proton is going to be another molecule, another carbocation, which can now be attacked by another molecule of the carboxylic acid. So in this way, by using this alkene as the base, and as we said, it could be anything. It could be the conjugate base of sulfuric acid could remove that proton. But when it's the alkene, we generate a carbocation that can now be attacked by the next molecule, and the reaction continues to go. Once again, the reason we're in this boat in the first place is we have to make sure there's no water in solution. If there were water, then water would be what attacked the carbocation. So with no water present, we have to use something else as our conjugate base, or the base that removes this proton, either the alkene or the conjugate base of sulfuric acid.